Hello everyone and welcome to another IGCSE Mathematics tutorial. Today we'll be going over the fifth topic, ratios and proportion. Ratios. A ratio is a way of representing how many of something there is compared to another. Ratios can be represented in this form, x colon y. Keep in mind that ratios are not restricted to two values and you will often have to solve problems with three values. When working with ratios, it is vital that you know how to simplify them. Take an example where there are 20 apples, 15 oranges in a fruit basket. This can be written in the following form, 20 apples to 15 oranges. To simplify this, we simply divide by their highest common factor, in this case 5, to get 4 apples for each 3 oranges. Sometimes you'll be asked to simplify more difficult types of ratios. You may be asked to simplify ratios that include decimals, or to simplify ratios that include different units of measurements such as meters to centimeters or kilograms to grams, or to represent ratios in the following form, 1 of something to each n of something else. To simplify decimal ratios, multiply both sides by 10 until you remove all decimal places, then simplify as you normally would. For example, for 4.5 to each 1.5, we multiply both sides by 10 to get 45 to each 15, then we divide by 15 to get 3 to 1. If there are more decimal places, for example, say 4.57, we'd multiply by 10 and then by another 10 to get rid of both. To simplify ratios with different units, convert the larger unit down to the smaller unit and then simplify normally. So if you have meters to centimeters, you convert it from meters to centimeters, and then you do the ratio between both centimeter measurements. To write ratios in the form 1 of something to n of another, divide both sides by the number you want converted to 1, and then you will have your answer. For example, for 20 of something to 5 of another, we divide the 20 by 20 and then the 5 by 20, which would give us 1 to 1 quarter or 0.25. Don't worry about decimal places for this type of simplification because it is expected. We'll move on to proportion. There are two types of proportion, direct and inverse proportion. We'll start with direct proportion. When we say two things are directly proportional, we mean that they will always increase or decrease at the same rate. For example, if a worker gets paid $10 an hour, he would be paid double in double the time. So 2 hours he works, he gets paid 20. If he works 3 hours, he gets paid 30, and so on. We can express this in this form. We can do, that symbol shows the proportion. We can do y to the cross into the x, or we can do y equals kx, where k is the constant of proportionality. Note that the k does not have to be a positive or even a whole number. It can be negative or it could be a fraction. Now we'll take a look at a problem that involves direct proportion and solving for the constant of proportion. Let us take the previous example. We will set y as the amount the worker gets paid, and x is the number of hours he works. To find the constant of proportion, k, we simply use one of the given sets of values. So we have $10 per hour, 20 for 2, and 30 for 3. We will take y equals to 20 and x equals to 2. To solve for the constant of proportion, we simply set the values in the equation and solve for k. So we'd say 20 instead of the y, we'd say 2 instead of the x, we'd get 20 equals to 2k. To get the k, simply divide 20 by 2, you get 10. To ensure this is correct, make sure to test with another set of values for the given y. So if we take the other set, 30 for 3, if we try solving y equals 10 times 3, replacing the k with 10, you'd get 30, which means the value is correct. Note that the equation y equals 10x, in this case 10 is the k, would always result in a straight line passing through the origin when plotted. That is the case with any set of directly proportional variables. The equation will always be in the form y equals kx, and it will always result in a straight line passing through the origin. Now let's take a look at the other type of proportion, inverse proportion. If two things are inversely proportional, that means that when one of them increases, the other would decrease at the same rate. For example, if two construction workers take 5 days to complete a job, adding 2 more workers would double the amount of work done. Therefore, the time to complete the job would be halved. We can express this in this form. or by saying y equals k over x, where once again k is the constant of proportionality. Once again, note that k does not have to be a positive or a whole number. Let's take a look at another example. Once again, we'll set y as the time taken to complete the work, and x is the variable as the number of workers. We'll solve for k by solving with the given values. So we'll set y as 5 and x is 2. To get k, we'd multiply 5 by 2, which would give us once again 10. Make sure to test again with other set of given values to solve. So if you try solving y equals to 10 over 4, now we're doubling the amount of workers to get the y. The time taken would be 2.5, which would give us half the value, confirming that the k is correct. Note that this equation for y equals k over x would always result in a reciprocal graph. It approaches but never touches each axis. That is the case with any set of inversely proportional values. The equation will always be in the form y equals kx, and it will always result in a reciprocal graph. So if the y increases, the x would decrease, and if the x increases, the y would decrease, but it never touches either axis. Thank you for watching. Make sure to like the video, subscribe, comment any feedback or questions, and check out our channel for more videos.